Okay, I'm back. So let's take a look at the universal timeline and see how all of this could possibly happen with the idea of panspermia, all the way from the beginning of the universe to when the Earth was created, along with several other things that may have happened in between and after. So, to try to make all this make sense, we're going to use a few things that we know, along with a few ideas of things that could have possibly happened on ways that life could have started. So, one of the first things that we do know is the universe started somewhere way up here at the top. Universe started 14.7 billion years ago, right here. And then all the way down here, we have Earth. That is 4.8 to roughly 4.5 billion years ago. So that's when Earth happened. So next on the timeline, we have the first sighting of life, which is going to be right around here. Prokaryote. That's what, 3.8 billion years ago. Now, after that, we have a few events that are key to mention, at least early on at this point. Somewhere around the 3 billion year ago mark, we have photosynthesis and mantles overturning. That's at the 3 billion year mark. Okay, one of the next things we have is right around here, we have the first sign of evolution. Now, that's the first sign of evolution. This is when prokaryotes became eukaryotes, when they turned from a single cell organism to a multi-celled organism. So for us, this is a big deal because this is evolution, that things may start to get bigger and better. And then one of the next important things that we're going to look at is right around, let's see, I'd say right around here. This is the Cambrian explosion. Now, as we learned in the chapter, the Cambrian explosion is where after one of life's other big events, that things started to really kick off. Life really started to develop after that point. Now, that's something that I really, really want us to focus on. But before we get to that, we need to also look at, well, there's life. Where does it come from? Well, so one of the possibilities that I just put on the board was Methuselah, because we don't know where life definitely came from, but we do know one thing, that one of the oldest planets in our universe is Methuselah. Methuselah it's about 12.4 billion years old. So that puts it right there at the top, close to after the universe first began. So again, 12.4 billion years ago. So now, what I want to do is we want to look at that is when that rock started. We see when our rock or planet started, and then we see how long after our planet started until the first sign of life. So if we say that Earth happened at 4.8 billion years, and then prokaryotes, the first sign of life, happened at 3.8 billion years, we're looking at roughly 1 billion years from the time the planet was formed until the first sign of life. So let's use that same math with Methuselah. So if Methuselah was created at 12.4 billion years, then it'd be pretty safe to assume, or pretty safe to guesstimate, that possibly life on Methuselah happened at about 11.4 billion years ago. Okay, so now I've got that on the board. Now let's take a look at the next thing that we know. We know that it took roughly about, let's say, okay, so, sorry, well, that's where I left off. So let's say that evolution on Methuselah happened 2 billion years after the first sign of life, just as it did for us. It took about 2 billion years from the first sign of life for life to evolve. So let's assume that that happened. Well, that happened roughly at the 2 billion year ago mark. So we're at 9.4. Now let's look at something else that I didn't quite put on here, but we see the 0. This is where we are now. This is our evolution level where we think we are pretty intelligent. So from the time of the first sign of evolution, that took about another 2 billion years. So let's use that same math right here to be intelligent life. Intelligent life 7 billion years ago. Okay, so now let's assume that we've got intelligent life on Methuselah 7 billion years ago. So what's the next step? They continue living on that planet, they continue going about their life, but then we have something else that I, again, didn't mark on this first side, but we also know that our star, it's going to burn out in about 5 billion years. So somewhere here, let's say negative 5 billion years, 5 billion years, that's when our star is going to burn out. But somewhere around here, in another 1 billion years, we're going to move out of our zone of habitable space, or our habitability zone, sorry. So we know in about another 1 billion years, we're going to move out of our zone of habitability. So let's just assume that right here, this is where they got to start figuring stuff out. Leaving zone. Okay, so that's where they have to leave the zone of habitability by that date. Now, here's what else we know. Let's say they do have to leave by that date. Well, they've got to travel. They've got to get somewhere. So what we know is that at least if they're at our same level of intelligence, then it would take them about 12 and a half light years to get from there to here. So 12 and a half light years is only, 12,500 light years. That's not much. So if they were to leave right about now, and let's just assume that maybe they even have a little bit more time, then they definitely have time to make it to Earth, or to even make it to our solar system, even before Earth is even here. They have time to at least set their spores in the right places so that as the Earth is beginning to form, it can become a part of Earth. Now, in one of the ideas of panspermia was radio panspermia, which is the suggestion that the universe is just teeming with those spores out there that are constantly floating. It's not like it's just one ship that's just sitting somewhere. There's multiple spores that are everywhere. So they're going to be landing on various planets. They're going to be evolving. They're going to be relocating as things are getting destroyed, as asteroids are flying. They're going to be moving around constantly. So with that being said, they're still floating in the universe and still maybe even on part of Earth as it's going through its different uh, uh, events. It's going through its greenhouse era. It's going through its hothouse era. It's going through various forms. But that life is here. So what happens is, as that life is here, it slowly starts to develop because it's already here. It's developing right here. It's had the time. It's already developing. And then we have this key right here. Photosynthesis and the mantle's turning. Now, in our books, it teaches us that these are two separate events, two completely different things. But what if one is a cause, one is an effect? What if, because these spores, these molecules, this Molly, as I introduced you to, this little creature is hiding or laying dormant in the crust or the mantles of the earth. So as these mantles are turning, these spores are coming out, which is giving life, giving photosynthesis. This is all happening right here. You see how the timeline is moving. You see how now this life fits into our timeline. Now, this is just a possibility. Now, another thing that I want to point out is, again, the universe is still teeming with all this life that's out there, all these tiny spores. And on Earth, we are still experiencing multiple events. There's multiple asteroids that are still colliding with Earth. There's our ozone layer is barely forming. A lot of things are happening. But one thing that we do know is we have this Cambrian explosion. The Cambrian explosion is the explosion of life where everything just went boom. Now, to me, that says that life was moving slowly. So life moved very slowly for about 4 billion years. Well, let's say about 3.5 billion years or so. About 3.5 billion years or so. Life moved slowly. And as it's explained in the book, one of the reasons that it happens so slowly is because elements, they have to undergo several changes. They have to change each time they interact with a new element. So that, as we can see, has taken billions of years. But then all of a sudden, in the last 600 million years, things blew exponentially. Maybe that is because during the time that these spores were out there in the universe, those spores continued to come back. They continued to land on Earth, and it had to wait until Earth was in the right state, the proper state for it to be able to actually grow. And that's why the Cambrian explosion introduced so much life. Now, the one hole in all this logic about panspermia, about life on Earth being created from other life, we have to ask ourselves the question, where did the first life come from that may have happened right around here? Where did it come from? If it came from another planet, what planet? Because Methuselah was, I believe, the first. If it happened by any other means, if it happened the way our textbooks explain it to us, through the different changes in the different elements, then if it's possible to have happened then, why is it not possible to have happened now? Those are things that we don't know the answer to. But we at least have some sort of building blocks for a conversation. So thank you for hearing me out. You guys have a wonderful day.